Good morning. So I'm joined this morning by Mark Ryan from Normet, Nathan Cables from Zerotech, Christoph Muller from Virturail, Uwe Senna from Implenia, and Marc-Andre Beck from Grivix. My name's Daniel Owen from Armstrong B2B. I'm going to give you a short introduction to myself and to our business. What's important to understand is that industrial brands are in a deep transition. They're in a transition towards low and no carbon fuels and energy. They want to also enhance their brand presence and customer experience. Naturally, as I mentioned, the reduced travel has meant that they need to improve their digital and immersive demonstrations of technology. And also there is a rapid change in alternative fuels and energy which requires a way in which you communicate that. So the reason I'm here today is because I'm very neutral, which is exceptionally Swiss. But I can sit. I'm neither a contractor or a machine builder. I think and I'm a marketing person, so I'm here to be provocative and hopefully have some good debates. I won't touch on this. This is for later on that you can read a bit about us. But the sectors that we're involved in are the likes of automation and glass, industrial vehicles, building materials, marine engineering, but they're all heavy industries that are in this deep transition to decarbonise. So where we support brands are in two places. We either help them with communication, so on the left-hand side, Rental Group, who are the largest rental company for heavy equipment in Norway, have invested in the largest fleet of all-electric heavy equipment. And they wanted to communicate two things. One was that they've got this new all-electric fleet, and the second thing is rent, don't buy, because in Norway there's a heavy tendency to buy equipment over renting. So the idea was that we created this visual that you can plug in and take out as and when your business requires, but also it sort of demonstrates the electrification. And on the right-hand side, this is a 5 cubic metre compact sweeper for Bucher Municipal, who are the leader in compact sweeping, based in Switzerland. And unlike the combustion engine that was beautiful to animate, batteries don't move, so you have to have beautiful graphics that help demonstrate the technology flow and the benefits. So I know we're here to talk about battery electric vehicles, so we can make them look beautiful is the idea. So I know that the topic is around battery electric vehicle cost, but we must, if we just look up, the reason that this is being explored is because these heavy industries they must decarbonise at a rapid pace, and one of the known and proven ways in which that can be done is through electrification. So as I mentioned before, the importance of having sustainability at the core of your business is absolutely almost mandatory. Heavy users of energy and raw materials need to present their vision for a net zero world, and also having a strong ESG rating can provide a competitive advantage. It's also important to visualise your proposition in a really strong way. So on the right hand side there's a business called Sorg, who are the world leader in furnace technology. So we proposed that they launched their vision, which was called Mission by Sorg. In the middle is Encirc. They are the largest producer of container glass in the United Kingdom, and from a single source they can fill the bottle. They can make the bottle, they can fill it, they can prepare store-ready pallets, and they can distribute to source, making it the lowest carbon route to market for drinks anywhere in the world. And on the right-hand side, we work with a company called Dennis Eagle, who make an all-electric refuse truck, which is around 300,000, and a diesel truck, which is around 150,000. And our very simple graphic said there's no time to waste with the clock face. So I think it's, again, trying to get something that sticks in the mind. I also think it's important to make things credible. So we work with a business called Arconic, who are a multi-billion US business who manufacture aluminium, which again is very relevant because people are making things lighter. As they make things lighter, you need less sophisticated braking systems. You can use less energy. So that's a bit about me. But I think it's important that we start with some thoughts. So if you always do what you always did, you always get what you always got. And I think that's a really important thing that we must remember. So this morning, there's a show of hands. Ross Dimmick. I flew here yesterday, and you can click for sustainable aviation fuel. It's an extra 200 Swiss francs, and I chose not to. So, did anybody arrive here by electric vehicle or not electric vehicle today?
Okay, on the other end, I was an electric vehicle.
Are you an electric vehicle?
Yeah.
And did anyone stop for a coffee and take a disposable cup? Did anybody stop this morning for a coffee with a disposable cup? But yesterday I was coming through the airport, I take a disposable cup, I throw it away and don't think about anything. Today what we're saying is there is choice. Sustainability is not a law, it really is a choice, and I think something where things become, when we talk about choice, we talk about cost and convenience. So I also hear a lot about a business case. It's a business case, and I think this is where we move on to the cost thing. It's very easy to hide behind rational decisions. Rational decision says it's going to cost more, or I can't predict the asset value of this piece of equipment. But the emotional side we must tap into as well, and that's where I think it's important that we play to the emotions as part of this. What's important, and this is my last slide, is that there are 3 types of people: those that make it happen, those that wait for it to happen, and those that wonder what happened. And hopefully I'm surrounded by a lot of people here that want to make it happen. So that's the few slides from me. I'm happy to moderate.
Yeah, I would say Mark and I were talking about this on the way over this morning, and that cost part of it, like the economic benefit, is a really, really big thing, especially for mining customers, right? Like I think I've got in my presentation that nobody really looks at the total cost of ownership of a vehicle. So what you've got in mining usually is there's a capex budget and then an opex budget, right? And I think you alluded to the fact that rubbish truck was twice as expensive as the diesel one, and the same thing happens in mining, right? Like they've got this capex budget, and the vehicle might be 3x times of the diesel one, right? But that's how they evaluate it, because it's a capital expenditure. It's a procurement people looking at that, and then they throw it over the fence to the operating guys, and then that problem's gone away, right? So one of the things that we run into all of the time is nobody actually looks at the total cost of ownership of their vehicle over its lifetime, because of the way that we account for things in mining. So that's one big thing that I think we need to overcome, is because on the OPEX side, like an electric vehicle is like an order of magnitude cheaper to run. You get more availability out of it, you've got less moving parts, you've got less maintenance. Electricity is not free, but it's a lot cheaper than diesel. But we constantly run into that problem where nobody's looking at the lifetime total cost of ownership of the vehicle. You're in one bucket, and then the operating's in another bucket. So that's a big challenge for us.
By the way, not only in mining, tunneling, same thing.
Yeah.
I would think that this effect is much more visible even in tunneling, because mining companies, in the end, they calculate their total cost of getting out the materials, etc. But I think this is much more visible even in tunneling. You're right.
And it's also, if we offer for tunneling, I have to buy mostly special equipment for that project, and I have to do the costs on that project. And at the end, if I offer, the project costs are that as what is valid. So the client says, too expensive, go away. So for me, the costs are really over the project important.
And this is an effect which is very disturbing, an economic effect which is very disturbing, because if you run a diesel vehicle on one tunnel project, okay, now you can say it is written off, but all the main electrical components, the main high voltage components, they do not wear during one project. Yeah, so you normally would have to write it off over its lifetime to be real.
And for us as tunneling, it's also important. We do have people in the workshops, electricians, mechanics, but they are standard people. If I go to the high voltage battery and electric things, I can't let them work on that equipment, so I need specialists for that one.
There's a skill level issue.
Which is then by 24/7 working time, quite high cost factor for me.
Do you not have a high voltage guy for your jumbos?
No.
And how do you see owning versus renting? in the future developing?
No, not only renting, we also sometimes purchasing, because if the equipment is going, like in Munich now, it's going for 8 years, we purchasing.
Okay.
But after that we give it away because we don't need it anymore for another project. Some equipment we have permanently, but most equipment we are buying just for that project. And then we have the project costs.
I can imagine that the future business models, especially with battery electric vehicles and tunneling and construction, the future business model will be a contracting model rather than buying and selling and I own drivers, etc., etc. I think the final model will be a contracting model where, by example, a transport power or a transport volume, ton kilometers are bought.
I don't think that we will do it like this.
Yeah.
Because it's quite simple. If I rent an equipment, I pay the rent, and that's every time I rent. If I buy an equipment because I say maybe I can use it, I don't know, but maybe I can use it next time, and I have paid it with all the interest and everything. In the next project, I can think, okay, it's paid. How I do it in my own calculation? I could put it in for 0, and then I have an advantage. I don't have that one if I have to rent it again.
Part of my presentation today is not to sort of preach to the you know the people that are actually interested in this. It's more just to talk about what we've learned so far, and I think that there is lots of opportunities out there for zero emission machinery, and depending on what your driver is. I was saving this antidote for my presentation, but I'll use it now. So lately there's been a lot of discussion in Australia about banning smoking on the ground. And at the same time, there's no legislation to say that they have any sort of, they're still legally allowed to drive Tier 2 engines underground. So you try to understand the irony behind this decision, and I think that's sort of the often the type of challenges that we face in industry. Is on one hand, smoking is bad for your health. On the other hand, we're breathing in diesel particulate matter daily, and because we're working in closed environments, ventilation is limited. That makes it quite a challenge for our employers. So for me, I think that going back to wait for it to happen, I honestly think that it's probably going to happen sooner rather than later. That this debate in Australia. Australia for me is one of the really good examples of how legislation and law, especially around safety, should work. So how it works in Australia, very briefly, is that they say that this is the minimum requirement. This is what they say. But we expect each and every one of you to reach as high as possible, because you are personally responsible for everybody that is working on your mine site in your tunnel. So as a result of that personal responsibility, in Australia, most customers do their very best when it comes to all the different processes to have the best possible technology in the mine, in the tunnel. So this discussion around banning smoking in a mine or in a tunnel, for me, I feel that finally the discussion is going in the right direction. That if somebody says, hey, you can't smoke here in this mine, and there's a 20-ton or a 30-ton machine with the diesel engine running right next to him, it sounds a bit ironic. So I believe that, truly believe that it's sooner rather than later, all of us will be faced with the challenge of removing diesel particulate underground.
I'll pick up on what Mark's saying as well. And so I had a theme about education and legislation, right? So everybody whizzes around in cars now, right? On motorways, 130 k's, 120 k's. When cars first came out, like internal combustion cars, you had to walk with a flag in front of it, right? Because it was so scary, and it was probably legislated by a guy that owned a horse farm or something. I don't know, but like it was 3 k's or 4 k's, and now you could do, and a guy had to literally walk in front of it with a flag. And now cars are normal, and it's taken 100 years. But I'm with Mark. I think things will speed up faster and faster, and it's not just education. Once legislation comes in, it'll just happen.
We are buying the equipment and we have their own workshop. And our workshop guys, like in Berlin on the site, are able to do 85% of everything on the different equipment on their own. And only for the last 15% I need the supplier. If I do this business with the supplier and the support from them, we have to calculate, because my guys are costly 70 to 80 euro, and if I call them, it's 120 euro per hour. So at present, there's a big difference in that one, and I have the guys to do mostly on their own. Also with the TBMs, we are buying the TBM, and we have 2 guys from the supplier, and everything else we are doing on our own.
Can we talk about the future asset value of something? As you know, we've seen it in the car industry, that you get 8 years, do you own a battery, and you buy an Audi e-tron 5 years ago and it was 170 miles. Now you're getting cars that are doing 400 miles on range.
Yeah.
As batteries get industrialised in terms of manufacturing, they become cheaper. What does that do? Is that stalling choices today for people buying new equipment?
I don't think so. And some of the stuff that I'll talk about today, I think what we generally use in our equipment versus the car industry is quite different. But even maybe if we stick to what we're familiar, which is the car industry, I think there is lots of businesses that are springing up with the actual focus on taking those cars back and reusing and repurposing battery cells. So an example would be that the car originally had a 400 kilometer range. The man or woman trades it in when it starts to lose its state of charge. Maybe you're only able to get 300 kilometers. But that battery still has a use, still has a life, still has a purpose. And there's quite a few already companies making quite significant money out of taking those batteries and setting them up so that when you can use them as energy storage. There's a company that in Switzerland at the moment, for instance, that takes crashed and used vehicles, removes the batteries, repackages them, and then sells them back to households so that when they have their solar panels, they can store energy during the day, and then in the evening they can take that energy and put it back into their household. So for me, actually, I think that particularly the battery area is the possibilities are really quite interesting and almost endless. Then when eventually the battery becomes, let's say, unusable, maybe that's the best word to put it, those elements are very easily, without that much energy, recyclable. And we can put them back in the chain again and reuse them and create the new batteries. So yeah, I think that we're only at the very, very beginning, because most battery cars are less than 5-6 years old. But you'll start to see maybe in the next 4 or 5 years that a lot of big industries will pop up, taking these industrial batteries, car batteries, and repurposing them and reusing them. And the nice thing is that most of that they'll be reused to create reusable energy. So it's quite an interesting and an exciting game. And if anyone has any kind of spare cash in the bank and wants to invest it in something, my advice would be to look at these types of companies, because I think they'll be huge in the future. For me, the exciting part of working with Normit is that we are an innovation company, we are a technology company, and we're a technology leader in our area of underground mining and tunneling. So what I wanted to do to sort of set the scene and to get everybody in the sort of right state of mind for this discussion today, I thought a lot, and I tried to reflect that how could I kind of put all of us, both in the room and online, in the right space of mind. I kind of thought about I've thought about sort of the evolution of underground operations. So we started off excavating tunnels and mines, and it was mainly manpower, it was mainly people pushing stuff around, and it was really hard work, and we did that for a very, very long time. And then somebody had this great idea, said why not get some ponies involved, and so in other words, mainly they were ponies because they were a bit shorter than a horse, and they started to, and so I think this is where the whole horsepower sort of analogy came from, was thinking about how many horses do I need to push something, and this whole thing came about. And you can see now things are starting to speed up. So then we started to with our first sort of mechanization. And I'll stop here for a second and sort of think and ask some questions. So when the first guys pushing the wagon started to see horses pushing wagons, do you think that they had any kind of issues or were surprised or worried? So I'm sure there was concerns at that time that will the ponies go bananas underground? Will they like it? What do we do with all the horse waste? So I'm sure there was all kinds of questions like that. When we started then putting diesel engines, there's actually a part in between that I decided not to put in, but obviously for a while there we were using compressed air machines as well, and so maybe some of you guys can remember that time. So we started mechanization, and actually during this time we also had battery powered machines as well. But then diesel started to really become the dominant part. But during this time as well, it was quite a perilous time, because again we were learning how to look after these machines, and quite a lot of accidents happened at that time as well. And then over time the mechanization process got better and better. And I feel then, if we think about today, I feel that I'm part of this next evolution, this next step that all of us have to take. In this scenario, we need to be able to remove diesel particulate matter from underground. We need to remove heat from underground. We need to remove, and we need to try and reduce and hopefully eliminate as much as possible CO2. So this is sort of the journey, and I feel that we're all now part of this next evolution. I've been really lucky to be involved and be part of this evolution. And Normet, when this challenge came to them, and came to us, let's put it that way, the easiest thing for us to do would have been, let's remove the diesel engine, let's put a battery where the diesel engine was, let's keep everything else the way it was, and let's move forward. And that was going pretty well for us for a while, and then we realized that if we were to do that, each and every machine would be slightly different. It would be quite complicated to build it. It would be even more complicated for our customers to look after it. So we realized very, very quickly that we needed to go back to the drawing board and come up with a standard battery module. So today, in our M-Series platform, we use the same batteries, we use the same axles, drive motors, inverters, so that regardless of the application, the battery module is the same. The power module is the same. I'm not going to spend too much time on it, but this is pretty much my energy is going into this part of the evolution, of the journey. Now, today with Normet, we have over 60 units operating globally. And we've learned a hell of a lot. We've also got about 75, actually I think it's a bit more than 75 trained and certified professionals in 14 locations. This is a must. For us to have this brand new technology in the market, we have to have the expertise to be able to manage and look after. And this is part of that process that we realize that you can't just say, John, there's your machine, hefty handshake and wish him well. You need to support, you need to help the customer. And the biggest part of this is not the maintenance. It's helping the customer understand the risks and helping them mitigate the risks. So the vast majority of the work we do with customers is around risk management. Okay, I decided then instead of, I could have put a whole lot of data up there. I could have put a lot of statistics together and bored the pants off you. Instead, I decided that maybe I talk about a customer and a journey. So our very, very first battery electric machine was the Spraymec 8100, the one you see in the photograph. So it was the very, very first machine that we produced. And anybody that was in Bauma, that was the machine on display. And then we took it back to the factory. We did quite a lot of spraying with it. We were in Puasalmi mine, which is less than an hour away from us. And we spent an awful amount of time driving it up and down the ramp and spraying with it. And then we had a fantastic opportunity. We had a contractor in Sydney who wanted 6 sprayers to work on the Sydney Metro Tunnel. And so I got on the phone and we talked a little bit about it, and we said, hey, wouldn't this be a fantastic opportunity? First, to be able to offer the customer the Spraymec, but also to be able to compare diesel Spraymec to our Smart Drive Spraymec. So we went about talking to the customer, and so we started the project with 5 diesel and 1 Smart Drive. And 2.5 years later, and a little over 7,000 hours. So this is the project. So you can see here it was this Roswell interchange. You guys can have a look at it. So it's part of this WestConnex network. One of the reasons why we selected this project was they had millions of cubic meters of concrete to pour. So there is no place to do any kind of testing like a place like that. So it basically, it was 24 hours a day, 7 days a week, Christmas Day, you name it, this thing was running. So what did the guys say? And actually I didn't do any editing here. This is directly from the customer. And it's easy to know these guys are Australian because the first thing they said is this machine is cool as, which means, if they translate it to normal, is that this machine is really cool. They said the operator says it's very quiet. Obviously there's no diesel fumes to deal with. There's no heat either. And they said that that's one of the things that the operators really notice with the diesel machines, is that they get hot. They also liked the fact that the pre-check was a lot simpler. So that was one of the big ones from the operators, is that they don't have as many things to check when they do their pre-check. They said the thing really hauls on the ramp, so they can get to A to B much quicker, and we've seen that with other applications as well. So we don't have the mechanical losses through drivetrain like we would with a conventional diesel machine. They said that the compressor was quieter. They also said that, what did they say here? Operators, they said that basically they fought over the machine. That you can understand that you have 2 choices. You stand and you run a diesel operated machine and there's heat and there's diesel fumes, or you don't, and you don't have all that noise. So they were saying that the fatigue side of things was clearly a differentiator. One of the things here too, and when often customers tell me that, it's too hard, we need all kinds of charging and all kinds of infrastructure. These guys didn't have any fast charging infrastructure at all. The only thing this thing did was it utilized the same gate-in box or electrical panel as the Jumbo. So it utilized exactly the same infrastructure that they had to put in anyway for their big drilling machines. And out of the 2.5 years, the battery went flat twice. Which I thought was pretty good going, seeing that they didn't have any fast charging or they didn't put any extra infrastructure in for this machine. Okay, so then the maintenance side. They said that less maintenance cost has no internal combustion engine, and that's the general theme. When I started to sort of crunch the numbers for the TCO calculations, I was expecting to really have to go very deep into it, but the actual reality on the ground is the guy said it's just really simple to be able to calculate. When you don't have the diesel engine, the costs and the let's say the time it takes to do the maintenance and constantly look after the machine is it takes a lot of the effort away. And there's less spare parts because you don't have that combustion engine. There's no fuel, and what they said that they didn't need to move the machine as much. Where the diesel machines, they had to refuel them every 4th shift, and that meant actually driving them quite far away because it was quite a big job. There's no hydraulic transmission to worry about, and also the consumables were pretty much the same regardless of the machine. But the last point was directly from their mouth, was that the cost of service was 75% reduced. And I think that's an important point here, is that when you take the diesel engine away, when you take all the other elements that you normally have to look after, all the oily bits are gone. It's a far, far simpler thing to look after. Now, how we managed it from a let's say, maintenance and service perspective is that we had somebody come on site maybe once a month from Normet to take a look. So that was part of the contract. And they just checked, they gave it the once over, plugged it in, had a look, and yeah. And to be honest, this is a sort of a real showcase for us, because this machine has run pretty much flawlessly since its start. The other thing that we've learned a lot about is that we don't have all our machines connected, but the vast majority are. And that has really changed how we deal with equipment. So we actively encourage, particularly our smart drive customers, to have some kind of connection to the remote monitoring service that we provide. And it's for two reasons. One, we can keep an eye on their machine. And if they have any kind of problem, we can give them a call and let them know. But the other reason is far more selfish. It's far more for us. It's for us to understand, how are these machines actually working? How is the battery performing? How is the different components performing? So the data that we get back is incredibly valuable for us to determine how well our designs are holding up, how well our safety systems are working, etc. So these are the facts. So I said we've well over 60 machines. At the moment, 57 of them are connected. And I managed to pull this data from our server. And I can actually pull my laptop out now, and I can go and look at anybody's machine that's connected there. Obviously, I'm not willing to share any of this information with you. That was the first idea, actually, was to go online and actually show you physically, but then realize that, of course, certain customers mightn't appreciate that. But for an OEM, at least, we can see that. So, for instance, quite often, a customer would say that, hey, I've noticed something funny. And I can go in straight away and almost immediately be able to figure out what potentially that issue could be. And that's really the power of the having this data service. So we have 57 machines registered. We have over 33,000 hours in operation. We have saved enormous amounts of CO2. We have driven 74,000 kilometers. What's really cool is the last line here. So the total energy used, the total energy charged, plus the energy regenerated. And this is something that's important for you guys to be able to get your head around. One of the wonderful things about what Normet does is the applications that we have generally works in almost direct opposite to, let's say, load and haul. So if you think about load and haul, generally the operation is that the machines go down empty, they fill up, and then they have to go up loaded. And that demand is quite massive. It's a massive amount of energy needed. Luckily for us, in the areas that we're operating in, it's the opposite. So we usually are fully loaded and driving downhill fully loaded and coming up empty. And that allows for us to be able to regenerate energy as we're driving down. So with our applications, we're able to regenerate energy quite significantly. And so this 96 megawatts of energy is a significant there's no such thing as free energy, but it's energy that's regenerated by the machine. And that's something that's quite significant. So these are the things we know. These are the things that we're monitoring on a daily basis. But I think the main point that I want to say here is that all this information would be available for you as a customer, and of course for us to be able to monitor and learn from the machines. So you can see here then, if we think about the different machines and the different applications, you can see how much fuel savings there are, how much CO2 savings, and how much energy they're able to regenerate. And so you can understand in say mining or tunneling, the applications can be infinitely variable. But you can see any type of transportation application really allows itself for energy savings and CO2 savings and fuel savings. The other thing is that we're able to really monitor the batteries and what they do and what kind of a window they operate in. And why is that important? We're able to see, we're able to understand, will the batteries last or beyond the life of the machine? Are they up to the job? Are they good enough for the process? So if you can see here the green line, you see the amount of charges and the amount of cycles the machine is doing. And you can see up here, we put a Christmas stocking. And there's a slight dip. That was Christmas week. And they didn't use the machine.
Too many gifts.
They had too many gifts. So that's Christmas week. So you can get the idea that this machine, this green machine, is being used like it never stops, apart from Christmas Day or Christmas week. Then the machine had a bit of a rest. But you get the idea that the power of being able to capture and understand that data. Here's one looking at the temperature range. So we know that for our batteries, the temperature range is to be able to make sure that the batteries have the best possible life. We need to make sure that they're in the range of, you can see here the percentage of time, and you can see then the ambient temperature range. And for us, what we're seeing in various parts of the world, some of those, I think the blue line, it's in a very, very warm part of the world, but still the battery is working in that optimal range. So that's telling us that our battery cooling is working and is effective. And we can see here that we look at the fact that over time, the batteries are operating in that optimal window. And then the state of charge. So we look at how low the batteries go and how much over, let's say, charge beyond 90. And obviously the optimal window for us is between 20 and 85. And you can see that the majority of the time these machines are in that really nice optimal window. So these are the kind of things that really help us when it comes to making sure that our applications are safe. And then we try to project, or we can very accurately project now, that the manufacturer of the batteries, they tell us that these batteries are capable of 20,000 charge-discharge cycles, but we already know from the data that we've collected that they'll go well beyond that. So again, it gives us confidence when we talk to customers, we actually have the data to back it up. So the conclusion from the data: continuous operation, significant daily hours. We're seeing significant fuel and CO2 savings. This regeneration of braking energy, it decreases grid electricity usage significantly. And actually, quite often people forget that batteries are also energy storage devices. So, you know, you can optimize your energy requirements. The batteries, from the information that we have with the machines in the field, are expected to go the whole lifespan, actually probably a bit beyond the life of the machine. And we've seen already that the components are staying within the optimal design, temperatures, state of charge, etc. Thanks. Okay, who's next? Do you want to swap seats? Swap quarters as well. There we go.
So I'm Nathan Cables. I'm fairly new to the battery industry. I work for a company called Zerotech that's based in Galway in Ireland. But my background has been probably for more than 20 years now in mining technology. So I've worked for companies like ABB, a company that was purchased by Trimble. So I've kind of always been around the mining technology space, I suppose. Which one is the?
It's the one that's
that one there.
Worn out. Yeah.
So I'll just give you a little bit of background about Zerotech. So as opposed to some other battery companies, we specialise in off-highway vehicle batteries, and rather than on-road vehicles. And the reason for that is, with on-road vehicles, there's very, very low variability in the application, right? So you're making batteries for trucks and cars that drive on highways. Cars have very, very similar footprints. They use a kind of a skateboard design, and are not in a rugged environment. So we made a conscious decision, or the founder of the company made a conscious decision to concentrate in batteries for off-highway electric vehicles. And because of that, we've got batteries that are quite significantly different from the batteries that go into cars. So we've got batteries that are encapsulated in fire retardant foam, which is also to deal with vibration, like high vibration in an off-highway application. And we also have ducted cooling, which uses a water glycol mix that goes through each individual cell, around each individual cell within the battery. And so that serves two purposes. Like Mark said before, keeping your battery running at an optimal temperature is really, really important. And so the system enables that to happen. It keeps the batteries at a consistent temperature. But if something goes wrong and you're in an underground environment, or any kind of environment actually, you want to stop that battery catching fire and melting down. So what the glycol does and the foam does, as well as acting as a coolant and a buffer for vibration, it actually works to seal off the batteries and put out the fire itself. So it's specialist batteries that we make that only go in off-highway vehicles. So I think a lot of the presentation that I'm going to talk about, Mark's already talked about and we've already discussed here, is the benefits of battery electric vehicles are these really. I don't want to run through all of them, and I've got a very short presentation compared to Mark's, but that's all right, mate. I'll just kind of echo what he said, right? Like you've got reduced energy consumption costs. So you've got the regenerative charging benefits, but you also have, as you reduce emissions underground, one of the massive costs you've got in an underground environment is ventilation. So we were at a mining conference a couple of weeks ago, or probably about a month ago now. That company has fully embraced battery electric vehicles, right? They're making a transition to battery electric vehicles over the next kind of 5 to 6 years. And one of their key considerations is having the right infrastructure in place to allow for the charging, but they're also factoring in the lowering the ventilation costs. But they've calculated that at the moment they use about 3% of Sweden's power grid. When they go fully battery electric, that demand will probably go up to something like 33%. So that's a massive change and a massive challenge they have, I suppose, to go fully battery electric from the conventional diesel. I'm not going to run through these all because we've talked about all of them, but I will say that regulatory compliance is one thing that's really going to drive the change. So it's not just companies wanting to do this themselves, it's actually legislation coming in that's going to drive that change, right? So if you're staying ahead of the curve as a company, you're going to get hit less with the stick rather than staying ahead of the curve. So I can see that as soon as regulation comes in, there's going to be a massive change, and I think it will happen fairly rapidly, and you're going to be scrambling to keep up, because if somebody comes in and says from X date no longer we're going to have diesel underground in a tunnel or in a mine environment, you could be in a situation where you're 2 years behind the legislation. You know, you might be in a massive queue because there's not 10,000 companies in the world that make underground mining equipment. There's a handful, right? And you guys all know them. And if somebody says legislation starts from day X, you don't want to find yourself in a situation where you're scrambling to catch up and you're putting yourself at risk of being out of compliance. So I think that's kind of a consideration that we've got in the market at the moment. Some of the things that always come up around safety, and I've put this as a consideration, and this is one of the challenges, right? Apart from the legislation driving change, you've got these things always come up. Is when electric cars first came out, everybody had that range anxiety. I know I did, until I've got an electric Volkswagen at my house, and until I actually had a charging station sitting there, I was always worrying. Like, I'd still have 300 k's left on the clock, but I was worrying, where can I get a charge? Am I going to be stuck out in the countryside somewhere? And that's a big concern in the market. People have still got that range anxiety, and I think that's tied to education, right? So I said when we were talking about before, it's legislation and education that'll drive that. It's there's no need for that range anxiety if you have the right infrastructure in place. And I think one of the things that you said, Mark, was you've got the sprayer underground in Australia, and you've got 5 conventional and one BEV under there. It's good when you've got one BEV. You don't need the additional infrastructure. But if you're going to have your whole fleet electric, then there needs to be infrastructure around it. You can't just have one charger that everybody's trying to queue up for and use. You need to consider the whole system. So you need to make sure that you've got like the OEM on board. You make sure you've got a charging partner on board. You make sure that you understand the battery that you're using is going to be fit for the purpose, because there's no such thing as just one battery and one application as well. Like there's different power requirements, there's different chemistry requirements, and they all need to be considered as part of that whole fleet management and how you manage things going forward. And now I've just put a little bit about safety there. Like so Safety always comes up, and we talked about that a little bit before, but the ADF is the Australian Defence Force. They're going through electrification projects as well. We actually do a lot of work with military customers around hybridising not fully electrified vehicles, unless they're in special forces applications. But they're hybridising a lot of vehicles at the moment, and we've actually got a US military customer that's got a lot of our packs over there at the moment, and they're actually literally going to blow them up to see what happens when they come under fire. So and how safe they are, how they react compared to like what they've got with diesel. But the Australian Defence Force commissioned a study as part of their project to electrify and hybridise some of their vehicles, and their study came back with the risk of fire from an EV, like just as something going wrong and blowing up, was, what's that, 0.0012% versus 0.1% for a combustion engine, right? So that's an order of magnitude safer, and I think that's one of the myths that we encounter all of the times, are that electric vehicles are not as safe as internal combustion engines, but you're not driving around on a massive tank of combustible fuel with an engine that's exploding thousands of times a minute, right? So that's how the engines work. So I think that's one thing that we need to overcome in terms of education, is that safety aspect of things, and included like the lack of emissions and just the lack of risk of storing fuel underground and all that. So this is just a little bit about how we work. So we make, like I said, the battery systems that go underground. They're designed to go into advanced equipment, so autonomous machines is a lot of what we're seeing. So the trend in mining, and I'm not sure about tunnelling because I'm not as up on that, but I know in mining, as mines go deeper and deeper underground, they're working towards completely autonomous operations, right? So they don't want people working 6 kilometres underground. They want vehicles that can charge themselves, be run remotely or autonomously, and batteries play a big part of that, right? And I'm sure that the OEM guys here are well aware of this requirement and are working towards that. And so that's, like these guys, like Mark was saying before, is that remote monitoring of machines is going to become more and more prevalent and more important. So we have, with our system, as well as all the safety aspects designed in, we have the remote monitoring built in as well. So you can actually monitor the battery on the machine via telematics. So most of our customers that we have are OEM customers, rather than just people buying. We do have a retrofit business as well, but most of the batteries that we make are going onto machines through OEMs, I should say. So again, like Mark said, the features of our batteries are we're getting lighter and lighter as we design our battery packs. So if you look on these sizes, that large one is about 2 metres tall, and you've got the smaller ones that are down around the 50 centimetre high mark. But we've got literally thousands of configurations of batteries that we can make to fit kind of any application. And as it's about every 6 months, you can see iterations of batteries coming on board. So you're able to get either lighter batteries, which means that the vehicles become more efficient, or you're able to get more power for the same weight. So about every 6 months now, we're seeing cycles where the technology is just improving and improving and improving. And like the guys were saying before, is an electric car could go 300 miles 5 years ago. Now you're getting 400, 500, 600, right? So you're seeing that order of magnitude improving all of the time. The systems are can fully utilise recapture, so that recharging, like Mark said, and regenerating, same as an electric car. There are remote monitoring, as I mentioned, but I think I'll just reiterate it. The most important thing that we do, which differentiates ourselves from companies that make on-highway vehicle batteries, is all of the safety systems, right? So we've got every system that we have on our batteries has 2 purposes. So it's kind of the design philosophy of the guy that started the company, Dr. Barry Flannery. He he's kind of like every single system that we have is dual use, right? So the cooling system is also a fire retardant, the vibration system is also a fire retardant, and then the casing on the outside of the battery not only keeps the rigidity of the batteries inside the system, but again that's also a safety system. So everything that we do, everything that we design into our batteries is designed to have a dual purpose. And that's actually all we do is batteries and monitoring systems.
My name is Christoph Müller. I am CEO of Virtual GmbH, an Austrian company manufacturing tunneling transport systems for tunneling. My personal background is that I'm working in, let's say, turning innovations into reality, especially in the mining and heavy industries since 1992. My first project actually was a completely remote controlled TBM, controlled from above ground in a German coal mine. So that's where I started, and we make things happen. So let's say this one is the one. Yeah, our company is a company founded in January 21, combines the expertise of tunneling and automation in some kind of a joint venture. The first joint venture partner is Mindtronics, or the operating company is Mobiletronics. These are my privately owned companies, which I'm running since '97. More or less, we have experience in autonomous machines, remote controlled vehicles. We do a lot of automation for also on-road vehicles, on-road trucks, remote control systems and stuff. And we also carried out the automation of the first tunnel supply train, which was diesel electric, but standing on rubber tires in the Brenner Base tunnel in the Arental system, the exploration tunnel, which was drilled there from 2015 till 2020 about. And the other partner in the joint venture is Jägerbau, an Austrian company with around 100 years of experience in tunneling and a lot of experience in design and operation of such, up to now they are called multi-service vehicles, MSVs, supplying tunnel boring machines, tunneling operations, etc. So we are dedicated to produce fully electric automated service vehicles, ASVs, for such supply purposes. And we want to provide cost-efficient, safe, technologically leading transport solutions. And that's what we are doing now in 2 projects. And I'm just giving you 2 examples. This is quite close to here in the Kerenzer Berg tunnel, on the safety tunnel on the motorway between Zurich and Chur. So just a couple of kilometers from here. There you see such a train on rubber tires with a lot of wheels. They all are electronically controlled, so all axles are running precisely in the same track, even in narrow curves and inside such narrow areas like here inside the backup of the tunnel boring machine. And characteristics is on the right hand side, this is the front. You do not see a cabin, you do not see a driver cabin. The driver sits on the remote side, just turning the seat in front of a video wall, and he is driving more or less automatically. He's supervising, he's just giving the throttle in order to run. This is the second project, and here it's already a little bit more designy, a little bit more spacey. This is the project which we have in Austria in the Kütai storage power plant project, pump storage power plant project. And here you see also, this is the site which goes into the TBM. No cabin, very easy to unload, and everything is fully electric. So every car, what you see here, is a separate vehicle. Every car is individually powered, has its individual high voltage installations. So this makes it very easy to operate, because you can simply take one car out of operation, put in another special car, or you can take one car out if you don't need it. You can add a car when you need it. This is an operation which usually takes about 30 minutes and is possible to be done by the people on site. Another advantage is, for safety, there are no high voltage cables in between the cars, which go from one car to the other, because they are salvageable, and there you are, even if you have all the insulation measurement things in place, you are not really able to control this to 100%, especially in this environment. And I don't want to make a big presentation. I just want to remind you on the first subspace energy hub thing about safety. This is our safety pyramid, which we apply to the battery systems, to the battery electric systems. I don't want to get deeper into it. It starts with mechanic protection and goes up to an emergency cooling, which is water powered by the water lines in the tunnel. So then I would like to get practical with you. And the topic is economy in battery electric vehicles. So just a few buzzwords about the economy's disadvantage. Okay, everybody says investment cost and charging time. Yeah, charging time especially. And there is the big difference to diesel. A diesel is very simple. I run my shift, I go to the filling station, I fill 800 liters, next shift 800 liters, next shift, nobody is asking how much this guy is consuming, the diesel is there nevertheless, the big vehicle nevertheless comes every 2 days, and that's it. Yeah? The advantages are, and quite many. We have a very much reduced primary energy cost. We have a high energy efficiency. We can recuperate. We have low maintenance cost, and we have less energy for ventilation. But this is also from the operation at the price of, in contrast to the diesel, filling, drive, filling, we need to synchronize our charging time with the operations of the site. Meaning that the goal should be that during the time when they load all the concrete elements and the concrete onto the cars, we also have to be able to charge the batteries. Yeah? Because otherwise we are blocking the operations. We are a bottleneck, so to say. So, and when we now have a look into the economic effects a little bit deeper, then we need to look here. Yeah? First I start with a direct comparison of a diesel hydraulic traction system, a diesel hydraulic propulsion, and the battery electric one. So let's start with the diesel. 1 liter diesel contains about 10 kilowatt hours, right? Thick thumb, no temperature effects taking into account, and so easy to calculate, easy to use. Yeah. And 1 liter of diesel, I calculated with 1.6 euros. You can also take something else, doesn't matter. Just a comparison now. The price per kilowatt hour raw primary energy, 1 kilowatt hour, 16 cents. And on the battery electric vehicle, let's say, and the one customer in Kütai now takes 0 here because this is the power company itself, yeah. But let's take 0.1. You can also take 0.2 or whatever. Doesn't matter. The dimensions count in this case. Yeah. But then the big things come. What efficiency does our diesel motor have? The best diesel motor at full load today has 41%. The best, the very best. This is world top. Yeah. If we calculate 35%. Then this is very generous in our operations, because we are never running the diesel motor on the full load curve. We are mostly running it on the part load curve. That's it. Yeah. In addition, the hydraulic traction. Hydraulic traction, maximum efficiency, 70% in a single pump, single motor configuration. This you can find a study of the Technical University in Munich. Having made these evaluations for an agricultural harvester, but there is not much difference. The pumps and motors are the same also on our mining and underground machinery. Yeah. So, and for the battery electric vehicle, we calculate roughly, I said now 90%. I took into my physics engineer, he said, okay, take in also the charging losses. So I said, usually we calculate for driving, we calculate 94%. We now said, okay, we take 90% and then we are fine. So in the end, we come out with, from 1 kilowatt hour raw up here, there is only a quarter remaining in the diesel machine, which is available for our traction, which ends up somewhere in the gearbox. This I didn't take into account. Mechanical losses I didn't take into account because they are the same. Yeah. So that's a quarter, and here it's 0.9 kilowatt hours, meaning that we can directly transfer this into a price for our energy, meaning that the euro per kilowatt hour effective at the entrance of the gearbox is 0.65 and 0.111 there. Yeah. So meaning that the battery electric vehicle comes to an advantage of 54 cents in this explanation. Just in this everybody can do this calculation for himself, for his own operations. Yeah. The big thing is here, because in the efficiency calculation, because you never reach these 70%. I'm coming back to the first diesel hydraulic trains which we had in the Brenner base tunnel and the exploration tunnel, yeah, because there were 9 hydraulic motors on 9 axles coupled to 1 pump in a closed loop system, which with terribly long pressure lines. Yeah, I mean, you can imagine the train is 40 meters long, and then you have 80 meters pressure line there. Yeah. So there, this efficiency was never ever reached. I know the extraterrestrial diesel consumption, but I will not publish it here. So this is really a generous calculation. Yeah. So then, when we now have a look at a sample project, and this is a project which we calculated in reality one time. The stroke length of the TBM anticipated 1.9 meters, the excavation length 10,000 meters, we need 5,264 drives, the total number of kilowatt hours per battery electric vehicle what we would have used is 171,647 kilowatt hours. This is related to 40 ton vehicle. And if we then end up at 92,000 euro in fuel cost savings, so to say, in anticipated or roughly calculated, or I had a friend, he was VP technology in Atlas Copco, some of you may know him, he already told about such things, I make a guesstimation, but he seldomly was wrong with his guesstimations. So if you say that we come up with such values here, then we can conclude that this cost advantage alone is higher than the investment cost for the battery. Yeah? And we are not taking into account any maintenance cost or something like that. This is just the energetic calculation, nothing else. Yeah? In addition, the battery and the other high voltage equipment may not be end of life after this project. I have to say that in this project, I need to emphasize that we had an access tunnel calculated of -10%, which was of sufficient length. So there was also a recuperation factor, meaning that this cannot be transferred to any project, but it is calculated specifically for one project. And this is also the difference to diesel powered vehicles. You always need to take the entire project into account. So you can't regard these things in an isolated way, like we do it with traditional machines, be it an excavator or whatever. Yeah, as a summary, we have enormous cost savings on the primary energy side, substantial savings on maintenance and combustion engines and brakes, etc. We already talked about that. We have a quite high component lifetime. additional operational cost savings come into the game, plus all the non-monetary and environmental advantages, bringing us to the fact that battery electric vehicles can be operated economically, basing on the project conditions, and in case we take into account the total cost of ownership, and not only CapEx, OpEx, like what was already told before. Okay, thank you.
Thank you.
Okay, once again for me, my name is Uwe Stenner. I'm working for Implenia Construction Tunneling in Germany. There I'm head of mechanical department, and Germany is also responsible for Denmark, Netherlands, UK, Ireland, and if it's TBM, also for Scandinavia then. I'm since more than 30 years in tunneling, approximately 50% on job sites, the after 50% in the headquarter supporting the job sites. I do it a little bit quicker, I don't have so much points. For the first point is, I'm also working in some other working groups like the DIN norms or in the what we call BEV, it's this union of construction companies in Germany, and also in the part where the Baugeräteliste, that's a big book where all German companies calculating their equipment according to depreciation and monthly cost, what they have to pay on the taxes. And in that book, I'm now responsible for the Group H, which is the tunneling equipment, and there we have to check if there's new things coming up and new prices and actualize the prices. And therefore we were asking, because we do for the BGL 25 now, and we put in for every equipment the part diesel engine, electrical engine. So that will be done for every equipment. Therefore I was asking more or less all suppliers for the costs. And I must say, for me, honestly, the additional price for electric is between 30 and 40% of the equipment. And then just coming back to the costs for the energy, we are calculating now in Germany, and if I see the prices, in Germany we can calculate the fuel a little bit lower, but the electric more than double of the price. Yes.
That's the
Really?
yeah.
So we are between 0.23 and 0.26 euro
So
per
fuel's
kilowatt.
cheaper than electricity.
We are the second highest price in Europe.
Yes.
So therefore the distance is much less,
Yes.
and when I compare to the 30%, it doesn't matter. What we are normally doing is I calculate what is the cost for electric equipment, and in the normal range I can save ventilation costs.
Yeah.
And the ventilation costs quite high because they are running 24/7.
Yes.
Which is at the moment we are doing like this. In future it will be difficult because there are new rules coming up for dust and small particles in the tunnel, and this BG Bau made measurements on different projects, and the measurement shows that the new rules, even when every diesel equipment is stopped, no diesel is running, we are over the limits. So we have to do much more work by, for example, we start now with our hydraulic hammers on the excavator. We put water spraying unit on the hammers, everything. But until we don't get it down, the only way is to keep the ventilation running.
Yeah.
So if I have to follow, if I don't find another solution, if I have to follow the new limits, I have to run the ventilation independent if I have an electrical vehicle or a diesel vehicle.
Okay.
So I don't save money there. That's the first point about the cost. Then I have the point with the working time. So we are testing that, get our circle times with the big equipment done. If that is okay, we will start with a very special project in Munich, hopefully in January, with the first time for us with a big electric wheel loader, because we have to use it as a compressed air tunnel, where we have the next problem coming up. It's a very special with compressed air, only electrical is done, and we ask the suppliers, what is the new battery type doing under compressed air? And everybody said, we don't know. So we are having, let's say, a test file there and see what happens. And we have additional costs because the fire department clearly says you can use it. If everything else is by cable, you can use the wheel loader with battery, but you have to load outside. So every time for the loading, I have to go to the airlock, come decompress, compress again, and fill the airlock with the air again, and it's a big airlock. So that's additional work and cost for me again.
You're using energy driving back and forth.
Then I have a point that is because we still keep some equipment in our own, and I have a not a continuous work for that, like in mines. I have an equipment, for example, I buy it, I use it for 2 years, I park it for 1.5 years in the yard, I use it for 1 year again, I park it 1 year in the yard. For the diesel engine, I fill up the fuel tank, I fill up the oil, and after park it outside somewhere, and after 1 year I load the small battery, I change the oil and the filter, and that's it. What is with the battery? Is that working like this? Do I have to do some more work? Do I have to do some more installation? What costs I have to keep that running in this times in between? And then for me, because I'm in this EN norm unit, and there we got the information about the new European battery things where we have to, well, I got only told, I don't know exactly, but I got told we have to follow up and to store and to give away if we sell an equipment, the battery lifetime. Then it's for me, do I have to do something with that? Is it only the supplier of the battery, or is it coming to me and I have to take care if I own the equipment? Then it's additional work for me, which I have to install and to do.
We can talk about that as well.
Yeah. And the rest is for safety. If the tunnel is, every time I get told if the fire is in the tunnel for the battery, there were very special dangerous fumes, and I have to clean the tunnel afterwards. And that's quite a big issue if it happens, even if it's not often happen. I agree the battery cars are much less burning than the diesel cars, but that's a point for me, and that's that's the main points for me where I have to see what as a user I have to deal with and what is coming up for me.
So thanks a lot. So I take over. My name is Marc-André Beck. I'm the CEO and founder of Gribix. So what we are doing, Gribix is doing charging station autonomous for heavy duty vehicles. We are charging in the megawatt range. I see things have a little moved on the slide, but it is already a big problem. Right now, we are guiding the vehicle with ultra-wideband positioning to the charging station fully automatically. Then we are, with our vision recognition with the camera, we are detecting the plug and we are plugging in fully automatically and charge right now at up to 6 megawatt. In fact, 6 megawatt is double as fast as filling in diesel. That's 9 megawatt, but you only get 3 megawatt out of this 9 megawatt, as you all know. We've discussed it. And I could talk about this for hours, but we are really short for lunch, and Aurora is already looking at me. Yeah. So I'm jumping it all, telling you that all the technology is validated and great. But what I really would like to show is here, this thing. That's 4,000 amps in the laboratory. It's a video. And you see these huge copper bars back there delivering these 4,000 amps. Then it's our connection system to our cable that we are censoring, of course. And then you see these very, very thin cables getting into these charges. So here we were charging at 4,000. In fact, it was 4,500 amps afterwards. So anybody's asking, is it a problem to charge fast? There are the batteries there, it's the infrastructure there, and we are in the middle. Just call us if you have an issue there. This is really moved around now. But I was asked, even though we are not a battery specialist, I'm doing 14 years of electric mobility. Just get yourself back 14 years ago, that was Stone Age. There was, there was no Elon Musk, there was nothing. And I was building electric vehicles back then. Later, I was responsible at Huber & Suhner for the cooled cables. So if anybody driving electric vehicles here, and you are at the Ionity or Electrify America charging station, you definitely had my product in your hands already. And I just thought we need to think it a little bit further, because we were only at 500 kilowatt. Here we are now at 6 megawatt. And I can tell you, you can even push this limit way further. If there's a request from the industry, we can deal with that. But I was asked to say a few things about the issues we have with batteries and combustion engine. And when Aurora was asking me that, I was like, combustion what? Because for me, it's 14 years of electric mobility. There's no combustion engines anymore. Who needs that? Is it really that you need them for drilling and whatever? But still, I came up with some issues that they're still here. One thing is batteries can burn, electric vehicles can burn. It's really incredible. If you have an accident with a car, with an electric car, and it burns, like a combustion engine one. But it's in the media, it's super funny. What I want to say is there are means to deal with batteries that are burning, because batteries are not just burning. Usually it's a thermal runaway, and you can mitigate that. You have special cooling systems, there are immersion cooled battery packs, and as long as you can recognize that, then you can cool it enough so that the thermal runaway is not spreading, you have no issue. So please, Normet, ask your battery supplier to deliver the right battery packs. But I don't consider it as an issue. Also, if you want to use a certain amount of energy and your battery has a certain size, it's always 3 times less than having gasoline. So with a gasoline car, you have always the bigger explosions. And yeah, gasoline, you cannot mitigate, you cannot cool it, it just burns down whatever you have. Yeah, I think that's what I want to say. And I have a little joke here. Just imagine we have the world now. We have the industry, we have developed everything, but we have no cars. No cars. And then your boss says, okay, I need 2 engineers and I have this idea. It's a thing with 4 wheels and 4 seats that drives around. Come up with some concept. So one engineer comes and says, okay, I take a plastic bag, put it under the child's seat, fill it up with highly burnable fluid that can easily explode, and then I create explosions in front of the car, in front of the driver, that will propel the vehicle. I was like, oh shit. I mean, and then you have the other guy coming up with, okay, I take a battery, an inverter, and some electric motors. Guess who gets to the crazy house afterwards? Yeah, so don't hesitate to reach out to us. We are open and interested in collaboration. We can charge really fast. We can do that all automatically. And I really want to speed here up, but I have one more thing to add to all these companies here. If you have a gasoline pump, it's always the same gasoline pump. And if you have electric charging stations or concepts in underground mining, I mean, you have Sandvik with their battery swapping things, then you have different charging connectors, you have all these things. Also, industry needs to unify, there should be one standard. We were working on MCS, you saw that in the initial picture, it's a megawatt charging system. We have done with CHAR and the ICMM, we have worked on the ruggedized MCS. In fact, Rivix was leading this work group. So this is available now. And you can do whatever you want, but I recommend to go to a standard to unify technology. And it's also a question of adoption. You don't want to invest in power electronics, just different ones for different vehicles that you have in your minds. Thank you.